to generate a binary string with size n, and we don't want any two consecutive zeros. Okay. On the first day, we're using the default search. On the next day, we're using the breadth search. Okay. When n equals 2, we have how many possibilities? We want to generate a binary string. Binary means 0 and 1. Okay, a string only contains two possibilities, 0 and 1. So we want to generate a size 2 binary string with no consecutive zeros. So what can we get?
2.
2. What are those? Actually, there are more than that. N equals 2. How many possibilities?
0, 1. 1, 0, 1, 1.
1, 0, 1, 1. Is that all? Yes.
Yes.
Because we don't want this, right? 0,
We
0.
know.
Okay, so when n equals 3, how many possibilities?
5.
Okay, give me
You
those.
can draw a tree.
0, 0, 0, 1.
0, 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay? So for n equals 3, they are
You
actually.
just draw the tree thing like you did before, and then.
Okay. A tree string. Okay, a tree string. Good thing. Because we talk about the depth search, breadth search. Okay.
Yeah.
So look, I was talking.
No, but
when
you
n
didn't
equals 3,
even draw
they
it.
are total a.
Whoopsie daisies!
A possibilities. Okay. Did you hit the camera? Okay. When n equals 3, they are total a solutions, and then only 5 are valid. Okay. Why they are a solutions? We talk about this, right? Because 2 to the power of 3, right? Each position has two possibilities. So 2 times 2 times 2. And the invalid ones are 0, 0, 1, 1, 0, 0, 0, 0, 0. Okay, so 5 plus 3 equals 8. Ryan, 5 plus 3 equals 8, and these 3 are invalid. Okay, so let's come back to this. Okay, so we can draw the tree, right? Remember, at the beginning, the root node is empty. And then if it's empty, we can have two choices for the first character, which is 0, 1. And if the last character is 0, we can only put 1. If it's 1, otherwise we can put both 0 and 1, right? So this has two branches. This can only have 1. This can have only have 2, right? This has 2. Okay, so this is the binary tree. Yeah, binary tree. And then we can use the depth search, breadth search. Okay, the difference between depth search and breadth search is pretty obvious, right? The depth search traverses the binary tree as deep as we can. The breadth search level by level. To use the depth search, we can implement using a recursion or stack. To implement the breadth search, we can use the queue, right? DQ, double NDQ. Okay, we cover this many times. So today we're going to use another approach. Okay, we want to generate. We can actually generate the size n from n equals 1. Okay, so at the beginning when n equals 1, there are only two choices, right? Look here. This is n equals 1. Yeah. How do we progress from n equals 1 to n equals 2? Yeah. And how do we progress from n equals 2 to n equals 3? Yeah.
Yeah, 2, 3, 5. Isn't it obvious? Ryan, explain. What's 2, 3, 5?
Options. The options here.
Yeah.
First layer has
This is-
1, then it's 2, then it's 3, then it's 5.
Okay, 2, 3, 5.
Yeah, even you can get your.
Okay, 2, 3, 5. Yeah, okay, so this is the number, okay, for the answer, 2, 3, 5.
Yeah.
But how, okay, n equals 4. Can you get it?
What?
When n equals 4, what's the number?
It is.
It is 1, 0, 1, 1, 0, 1.
So for 0, we can only put 1, right?
1, 0. What?
It's 1, 0, 1, 1, 0.
8.
Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay.
Tell.
Okay, so what are we doing actually from here
We're
to
doing
here?
the Fibonacci sequence.
Why is it Fibonacci sequence?
1, 2, 3, 5, 8, 15.
No?
Two-
2, 3,
But that's still.
5. Oh, actually, yeah. You're right. It may be Fibonacci, right? I didn't know that. Why? Can we do one more?
Imagine.
Okay, I'm running out of space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wow, actually it's Fibonacci number. Okay, so actually, look, when we are at n equals 3, we go to n equals 4. When we go to the next n, what we did is actually we take all the results of this row, and then we check if the digit is 0, we can only append 1. If it's 1, we can put both 0 and 1, right?
3,
Yeah. So the answer is
6, 7,
yeah.
9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20,
Okay.
21.
Yeah. Okay. So look, n equals 1.
Yeah, next one is 21.
Yeah, we don't need to prove it.
Okay. So we are interested
don't
in the
need-
result. Okay. Look at this one. N equals 1 is 0 and 1. So we want to get the n equals 2. So how do we get it? We just take everything here, 0, 1, and we check. If it's 0, we can put the 1 only. If it's 1, we can put 2 situation, right? So 1, 0, and 1, 1. Okay? Yeah? This is the 1. Does it make sense? Okay. 1 n equals 3. Look at this. 1 n equals 3. So we took everything here, right? We check. So if this is 1, right? The last digit is 1. So we can put 2. So which is 0, 1, 1, 0, 1, 0, and 0, 1, 1. Okay? And here, if it ends with 0, we can only put 1. So it's 1, 0, 1. Look, this one, 1, 1. So we can put 2 possibilities, which is 1, 1, 0, and 1, 1, 1. Okay? Does it make sense? And this goes on. I mean, it's kind of like iterative, right? Yeah? And now look at n equals 4. And we just go through this. And then we check each digit, right? Look, this is ends at 0, so we can only put 1. So 0, 1, 0, 1. This ends with 1, so we can put 2. So 0, 1, 1, 0, 0, 1, 1, 1. And this, right? Do you understand now, right?
And the next one is 21 for the
Okay.
tree.
Okay, so let me write the code, right? It should be very, very simple. So we just iterate. We take the previous result and we check every result, and we, based on the last character, we just append it. Okay? Append, which is the put another digit at the end. Okay? Define f and answer at the beginning equals 2 possibilities, which is 0 and 1. Yeah? At the beginning, there are 2 possibilities. This is here, n equals 1. Alright, 1. Now, for I in range, start with 1 to n. Okay, so current, we want to get a new row. For everything E in the answer in the previous one, then we check, right? If E, the last character, is 1, then we can put 2 situations, which is current plus equals E plus 0. And then if it ends with 0, then we can only put 1. So current plus equal E plus 1. Okay, and then after this loop, we basically take everything and then we check the last digit. If it's 0, we can only put 1. If it's 1, we can put 2, right? And at the end, we just need to replace the answer with the current. And then at the end, return answer, okay? Does it make sense here? The similar time and space complexity, okay? So O to the power of the n, okay? And then if we consider the string concatenation is actually times n, okay? What are we talking about today?
We're talking about how different solutions and how to solve that problem.
Okay, so what's the problem and what's the solution today?
The problem is you have an n with you write a number and then number. So when that number, you need to find every possibility of where there's no contact. If there's 0, then there could only be 0 or 1, and it had to be the digits amount or for the n.
Okay, and then what's the solution today? How do we get n equals 5 from n equals 4? These are the result of these are the result of n equals 4, right? So how do we base on n equals 4 to generate the result of n equals 5?
Well, if there's a 1 at the end of the 4th digit, you can add 1 or 0, but if there's a 0 at the end, you can only add 1.
Okay, yeah, that's true. Okay, so let me sum
And you
up.
can
Okay.
basically add 2 if
Yeah,
you,
yeah, good. Okay, so basically, when we given n equals 4, we want to get a result n equals 5, right? So we need to iterate of the result of n equals 4. Okay, and then for each one, we check the last digit. If it's 0, we can only put 1 at the end. If it's 1, we can put 2 possibilities. Okay, and we repeat this process, right? We repeat this process.
Okay.
Yeah.
Okay, that's it for today. Bye bye.